So let's start. So today we will cover sample and population. So sample and population are two major topics in statistics. So the word itself is clear, like what is sample and what is population. The word itself is clear, but still we have some confusion regarding samples and population. So we will discuss today in detail regarding sample and population in statistics. So almost all so can you hear me clearly?
Yes, sir, it's clear.
So almost all statistical studies are based on sample. So let's imagine, we need to identify the average height of 300,000 students, let's say, for example. And it's almost impossible to measure individual height of all students, right? So if we if you are able, in any case, if you are able to measure the height or something, anything else for all population, then that is called population. Like if we're able to measure anything of whole population, of whole data, then that is a population. And if we draw sample of, like, out of 300,000 student, if we draw a sample of 200 student to identify the average height of a student, then that is a sample, right? So population means my complete data set, and sample is like subset of our data set. Population is my complete data set, and sample is my subset of our data set, right? So let's say we we took 200 students, like we took a sample of 200 students. So 200 students should contribute all the students that are in 3,000 300,000 range. So the sample should not be specific to one population, and the sample should include all criteria, like for example, gender, is attended university. So sample should not be biased to one factor, right? It should not be biased to one group or one community, right? So it should include all the possibility based on the gender or age or attended university or his we can say his hobby. So it should depend on several factors to determine the sample of my population. So the method for summarizing my sample data is called descriptive statistics. So whatever the analysis we do on sample data is referred as descriptive statistics. So let's say, for example, for 200 students, if we do a computation like univariate analysis. Univariate analysis means analyzing only one field, one volume. Say, then that is univariate analysis. Uh, so in computation of univariate analysis, we can calculate mode, mean, standard deviation. Likewise, in bivariate analysis, bivariate means more than one field, right? So if we do a bivariate analysis, then we usually calculate Pearson's R, do regression analysis, right? So these are all referred as descriptive statistics. So we are summarizing our sample data. So our goal is to find. So our goal would be to look at 200 students and find the average height of entire population, right? So why we took sample data? so that we can identify the average height of entire population. So our goal is to identify the average height of entire population. So my population here is 300,000, right? So by looking at the sample data set 200 students, we're going to identify the average height of 300,000 students, right? So that would be our ultimate goal. So so from sample, if we get some information from a sample and derive population, that is through inferential statistics, right? So whatever information we receive from sample data, we apply that to our population, and that terminology is called inferential statistics. Looking at my sample data, if I draw some conclusion, then that can estimate my population. That is called inferential statistics. So we are looking at raw data and trying to figure out some solution, and then we will apply that solution to my whole entire population. That is referred as inferential statistics. So in sample data, the this is descriptive analysis, descriptive statistics. So in sample data, the mean is referred as this symbol x bar, and the standard deviation is referred as capital S. Whereas in population, the so this later is called statistics in sample data. In population data, we refer this later as parameters. So it's usually the U, capital U, and sigma, right? So these are the difference between sample data and population data. So if you are looking for sample data, you notify your mean with x bar and capital X. If you are working with population data, then you notify your mean with this symbol and this symbol. So this is your sample versus population. So as I said, inferential statistics, we draw a conclusion of a population based on data coming from sample. So by looking at sample data, if we draw a conclusion on our population data, the whole data set, that is referred as inferential statistics, right? So then you might have questions like, so how to draw sample? Like, how can we draw a sample, right? Because out of 300,000 students, we are looking at only 200 students. So the sample should not be specific to one group. It should include all varieties of data based on age, his hobby, right? His enrollment rate. So it should look at several factors. So to derive a sample data, right? So how to draw sample data? So sample, as we said, is a subset of our population, right? So we want a representative sample. Representative sample means the sample that covers the all factors like age, enrollment, birth date, uh, his hobby, all factors that is referred as representative sample, right? So we have three approach. So three method of. So we have three method of drawing sample data. So three method. One include simple random sample, where each subject same chance of being selected. So simple random sample, it gives it looks for several varieties and it randomly selects. So the first one is simple random sample. Second one is random multi-sample clustering sample. Random multi-stage clustering sample. This is my second method of drawing sample. And third one is stratified random sample. So in an interview question, you are even asked like how to draw sample, like what are the method of drawing sample from population. So these are the three main most popular method. The first one is simple random sample. Second one is random multi-stage cluster sample, and third one is stratified random sample. So simple random sample is a sampling method. I, as I said, this is sampling method. In this sampling method, so we have a population, right? So we have a whole population of 300,000 students, and what it does is so this 300,000 student is in one bucket, let's say, and from this 3,000 student, and it randomly picks 200 sample, right? So it don't this is not a biased data, so it randomly look for 200 sample, and then uh, it gives us the sample of 200 student. So every time this this process is random, right? So second one is a random multi-stage cluster sample, where in this sampling method, so we have cluster. So let's say my 300,000 student is divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18 groups. So this is divided into 18 different groups, 18 groups divided into 18 groups, and from 18 groups we randomly pick 8 groups, 8 groups, so that my data is around 200, right? So it makes a cluster of 18 groups. Out of 18 groups, it randomly selects 8 groups, and in 8 groups would have a sample of 200 students, right? So this process is called random multi-stage cluster sample. Cluster means group, multi-stage means we have multiple stages, right? So 18 groups, we have multiple groups. So out of the 18 groups, we randomly select 8 groups. So this is random multi-stage cluster. Then we have strati, stratified random sample. So in stratified random sample, what happens is, so here even we have a cluster, but instead of looking for one cluster, it looks for data within the clusters. So for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 12 cluster we have here. So from one cluster, it picks up like say 20 student, and from second like 80 student, from third like 20 student, 20 student, 20, 20, 20, 20, until with each until with each 200 students, right? So this is the stratified random sampling method. Is there any question in this three approach? Any question in this three approach?
Almost clear.
So, and these all these approaches are depends on what type of research we gonna conduct.
Yeah, it depends on, oh, yeah, it depends upon your sample data. Like if you have a data of like, let's say 3 or 4 groups. So let's say in a university you have 3 or 4 department, 3 or 4 department. So there are 3 or 4 groups you have, right? And from if you have that 3 or 4 multiple groups, then you can choose multi-stage cluster sampling or stratified sampling. But you have data for only one group, then you can choose for simple random sampling, right?
Okay, all right.
So bigger is better, like the sample should be large enough. So if you have a large enough sample, then that is more preferable, so that you don't have a bias in your data, right? So what is bias means, like specific to one group, right? Specific to one group or one type of data, or one type of data is called bias, right? So we should not have a high bias in our data, right? So high bias should not be there, should not be, we should not have any high bias in our data. So random samples should be, it should be as random as possible, and should be, data size should be huge, then that is more preferable. Then we have uh, a sampling distribution. So another terminology is a sampling distribution, right? So what is sampling distribution is, so uh, let's say you can see here boats, right? So in one boat we have 30 people. So they are traveling somewhere to attend some party, right? So we have 1 2 3 4 5 6 7 8 boats here, 8 to the 16 and 24 boats, right? So so in this boat, let's say my mean is 9.4, right? So in this boat, so population sample is same, right? And my mean is here 10.8, right? So looking at this people, we can uh, figure out that my mean should be nearly about 9.4 or 10, or it should range between 9 to 10 or 11, or 8 to 9 or 10 to 11. So it is highly unlikely that your mean would be somewhere about 19.2, right? Also, it's highly unlikely that your mean is 3.4, right? So so if we take a sample of let's say 3 boards, if we take a mean, then it's you can say that your mean is somewhere here, right? So what the sampling distribution tells is, if we look at the average mean of all the samples, so all the 24 boards, then the sample distribution follows a normal distribution. So it follows something like this distribution, normal distribution. It follows a normal distribution. So so if we draw an infinite number of from a sampling distribution, so this is my infinite number of samples. Here we can say like my sample is 8, right? 8 to 24 samples. So likewise, if we draw infinite number of samples, if we draw infinite number of sample from a sampling distribution means, this whole is called sampling distribution. Sampling distribution, right? So if we draw an infinite number of sample from a sampling distribution, it looks like a normal distribution, right? So so if we draw an infinite number of sample from this sampling distribution, then it should approximately look like a normal distribution. Normal distribution means my symmetric distribution, symmetric bell shaped curve, right? So it should look something like a normal distribution, where my mean of distribution is equals to mean of population, which means, so this all compute data is my population. This is all is my population, and this one is my individual sample, right? So what it says, the mean of a distribution equals the mean of the population. So whatever mean we have for individual sample, so here individual sample is 9.4, right? So mean is 9.4. So for whole population, if we have infinite number of sample, if we have infinite number of sample, then my mean of one sample becomes equals to becomes equals to mean of whole complete sample. So it becomes like 4.5 something, 4.2. So sampling distribution says if we draw an infinite number of samples from a sampling distribution, it looks like a normal distribution, and the mean of our distribution equals mean of the population. So this is my whole sampling distribution. So here we have 24 samples, right? So if this sample becomes infinite, then my distribution should look something like bell-shaped curve, which is normal, and my mean of my individual sample 9.4 will this becomes equals or close to my population sample, the whole population sample, which is nearly about 9.4520. So my mean of individual sample will be equal to mean of population whole sample. So if these things are, if we have such things, then that means this this whole process is called sampling distribution. If you draw infinite number of samples from a sampling distribution, it looks like a normal distribution, and the mean of distribution equals mean of the population, right? So this is called a sampling distribution. This is very important term, and it's often asked in interview questions as well. What is sampling distribution? And most people are confused regarding what's the definition, actual definition of sampling distribution. So any question regarding sampling distribution?
No, sir, almost clear.
So if you understand sampling distribution, then then we have a central limit theorem. So this central limit theorem is what this theorem says, that the sampling distribution of sample mean is approximately normal. So this thing is, so this sampling distribution of sample mean is approximately normal, provided your n is number of sample is 30. What does this mean is, so this is my one sample, right? So this sample is approximately normal. Normal means it follows a bell-shaped curve, right? So it follows a bell-shaped curve, provided your n number of sample is greater than or equals to 30. So this is what a central limit theorem is, and sample central limit theorem says this: the sampling distribution of sample mean is approximately normal, provided your n is greater than or equals to 30. So what is sampling distribution? So if you have infinite number of sample, then then it looks like normal distribution distribution where your mean of distribution is equals to mean of population. If we have this condition, then the sampling distribution of its sample mean will also be normal, provided your n is number of sample is greater than or equals to 30. So this is central limit theorem. This is also often asked, what is central limit theorem in interview question. What is central limit theorem is often asked in interview question. So any question here?
No, sir, not. No.
So we need to have clear understanding of what is sampling distribution, what does sample means, right? If you understand this, then what is normal distribution? If you understand this three term, then this, this you can understand central limit theorem easily. So in central limit theorem, the larger the size of your population of your sample, sorry, larger the size of your sample, the closer the sample mean is with respect to population mean, which means your x bar is equals to mu, right? So x bar is, this is my sample mean. Your sample is approximately equal, sample mean is approximately equals to, this is my population mean, population mean. And you smaller the standard deviation of your sampling distribution. So so if you have larger number of your sample, then your mean becomes closer to population, sample mean become closer to population mean, and your standard deviation becomes standard deviation divided by total root n. So this is the deviation that we see in the standard deviation. So higher n, lower your, so if n goes high, then standard deviation goes slow, right? So that this is what it is like. If your number of sample is high, so your number of sample is high, then your standard deviation should be small. So the deviation should be small. So these are the properties of central limit theorem. Sorry. So these are the properties of central limit theorem. So as I said, your sample standard deviation will be equals to standard deviation by root n. So if your n is 30, your standard deviation 0.737. If your n is 100, your standard deviation 0.2. It's decreasing. So when your sample size is large, your standard deviation is low. So this is the property of central limit theorem. So your mean becomes sample mean, mu bar x bar becomes equals to mu, and your standard deviation becomes equals to standard deviation divided by root n. So this is the standard deviation of sample mean, right? So what central limit theorem says? This sampling distribution of sample mean. So these are the this standard deviation for sample mean, right? So these are the properties of central limit theorem. So so we have three distribution, right? So one is population distribution, one is sample distribution or data distribution, and another one is sampling distribution. So these three distribution we have. So one population distribution means we have data for entire population, and whose mean is something like 900. Suppose, for example, the mean is this much, and your standard deviation is this. And your data slash sample distribution means we are looking for one particular sample, or one sample only, one sample only. For one sample, your mean is this much, your standard deviation is this much. So if we look for infinite number of sample, so infinite number of sample of 200 response. Suppose let's say respondent from a population of New York hipster. Let's say we have a 200 respondent from that has infinite number of sample. So if you have an infinite number of sample of, let's say my n here, I have infinite number of sample. So if I have infinite number of sample, then that is what sampling distribution is. That is what sampling distribution is. Well, we have infinite number of sample, and my sample mean mu is equals to population mean, mu is equals to sample mean, right? And if these things are followed, if I have a sample distribution, then my sample mean is approximately normal, right? Approximately normal means it follows a symmetric distribution, symmetric bell-shaped curve, right? Here you can see my symmetric distribution after using sampling distribution. This is what central limit theorem says. So if you have an infinite number of sample and your n is here, we have n greater than or equals to 200, then your sample mean is approximately normal. So this is normal, this is symmetrical bell-shaped, symmetrical bell-shaped curve, right? Shaped curve. So here my mean will be same, but my standard deviation will be standard deviation divided by root n. So this standard deviation is often known as standard error. Even we say standard error. Even we say. So these three distribution we should not be confused with these three distribution. So so if you have a sampling distribution, it follows a normal distribution where my n is greater than or equals to 30. So if I have a complete data set, then it can follow it usually follow because my n is larger. It follows a normal bell-shaped curve. And for sample data, it means we are looking for only particular for one sample. For example, here here we have 24 samples, and one sample would be, for example, this one sample. Okay, say this as one sample. Okay, so any question?
No, sir. So,
Yeah,
So
good.
in R, so I have added a script here. So for R the code we have here. So here what I will be doing is, so let's say if we need to generate three samples from 1 to 100, let's say, okay. So I need to generate three random sample from 1 to 100. So how to generate that in R is, let's sample bracket 1 to 100. I need to see three sample, three, right? And my replace equals true. What replace equals true means, so is if I draw one sample, if I from a bucket, if I take one sample, and if I choose to, I take one sample from a bucket and then again I replace it, that means replacement is true. So, so let's say this is my, so let's say this is my bucket, okay. So I have my data here. So what replacement equals, replace equals true means, I take, suppose I have a ball here, three balls or eight or nine balls here. So I pick one ball in one sample, and then again I deposit that ball in the bucket, and then again pick second ball, and again I deposit that ball in a bucket. So withdraw and deposit. Is what means replace equals true. If I do replace equals false, that means I only withdraw, I only take my ball from a pocket, but I don't deposit that again. So right now let's do replace equals true. So if we run this, then it will give me a random 3 sample. So if we run this, so here we can see the random 3 sample 39, 99, and 7. Again, if we run this, it will give another random sample 20, 20, 27, 11, and 49, right? Again, if we run this, the number changes because this is generating random sample of 3. From 1 to 100, it is generating 3 random sample every time. Okay, so now what I will be telling you is regarding central limit theorem. So I'm going to show the proof of central limit theorem in R. So what central limit theorem says? The sampling distribution of sample mean is approximately normal, right? So I'm gonna prove that in R. So so first I'm just trying to show how loop works in R. So we need to define a variable. Let's say we define a variable name new number, and new number is assigned as null. Okay, right now in new number we see null value. Okay, so is null. Okay, so to run a loop, to run a for loop, so I want to run a for loop 10 times. Okay, and I want to store my information in this array. Okay, so what this script will be doing, it will store my information in new number. So if I look at a new number, it will store all values from 1 to 10, right? So this is the for loop that is running from 1 to 10, and it is storing all value in new number, right? So this is how we write a loop. So any question till here? Okay, so now let's say I have assigned my sample mean to null initially. Okay, so my sample underscore means is initially null. Now what I am trying to do is I am trying to generate sample of 200 people. Like here we did sample for 3, right? So I am trying to generate sample for 200 people for 500 till 500 times, right? So what I am trying to do is, so in this example you had 24 boats, right? So here the number of sample was 30. Your n was 30. So in my case, what I'm trying to do is my here number of sample n is 200, and I'm trying to create. So here was my 24 boats. I'm trying to create 500 boats. Okay, and I'm trying to create 500 boats, and I'm trying to store the information in my sample mean. In sample mean, I'm trying to store that information, right? So if I run this, and if I look at my sample mean, Here you will see the sample mean for all 500 records. Okay, so here it was my 24 boards and individual sample mean was 9.4. So here we have 500 boards and my individual sample mean is, you can say, 290 39 for one, 259 for second, and so on. So now if we try to, so here what x is, so x is my 500. So the 500 boards, so x is my population, and 200 sample that we are calculating mean. This is my sample mean, right? So if we look at the mean of my population, that is x, okay, what we get is 250.5, right? And now if we try to look the mean of my sample mean, if I try to look the mean of my sample mean, then we can see the value is approximately close to population mean, right? So this is what my uh, central limit theorem says. Your sampling distribution should be in infinite, right? So here I have chosen 200 sample and I have run that 500 times, right? And if that is the case, then my sample mean should be equals to population mean. So my population mean is of 500 samples, 500 people, let's say. You can say 500 boards if you consider this example. And your sample mean becomes, you have for each board you have taken 200 people, right? So you have calculated sample mean of 200 people. And if you do this, then you can see your population mean is close to sample mean, right? So my population mean is 250.5 and my sample mean is 250.5003, right? So, and if this is the case and your n is greater than, so my n is here 200, so it is greater than 30, then this follows, if we draw a histogram of x, this is uniform. If we draw a histogram, because, so if you draw a histogram of my sample mean, here we can see it is following a symmetric normal distribution, right? So this is what my central limit theorem says. Okay, so to revise what I have told you again, let me write it down. So central limit theorem says I should have, I need to have, I need to have infinite number of sample, right? So here my sample is, I have taken sample of 200 people. So if I have a infinite number of sample, then my sample mean is closely equals to population mean, right? And if this is the case, then my distribution should be normal, right? So what we did here, so here my population was 500, right? So I have 500 boats, let's say 500 boats, and in each boat, so here my population is, I have 500 boats, and my sample, and in each boat my sample is, my sample n is here 200, right? So this 200 boat, we can say we have 200 again n is my 200. So this n is again 200. So this is repeated till n is 200. So this is repeated till 500 times, right? And what we did, we calculated mean of each. We calculated mean of each sample, mean of each sample, mean of each sample, mean of each sample. And then what we did, we took mean of my 500 boards, and again we took a mean of all all the samples that we have stored that in sample underscore mean. And if we look at mean of my all sample, this is my population sample, and this is my mean of, this is my whole population, and this is my whole sample mean. So we can see that my sample mean is closely related to population mean, right? And if we draw a sample of, if we draw a histogram, it looks like a symmetrical normal distribution, right? So this follows the central limit theorem. Okay, so this is how, so this is the mean. And if you want to calculate standard deviation, so standard deviation will be sampling underscore SCD will be standard deviation of x divided by square root sqrt of your sample mean. So my here my sample mean is, I have taken 200 sample, right? So if we do this, this will give me my standard deviation. Okay, any question regarding central limit theorem? Any question?
No, sir. No.
Okay, yeah, yeah, this okay, thank you. This concept you need to be you need to have a clear understanding of this concept, because this is the starting of statistics, this is the starting of data analysis. So this concept needs to be really clear. Okay, sampling distribution, what is sampling, what is population, what is central limit theorem, these things needs to be clear. So to test your understanding, I have added quiz questions even in quiz week 5. So I will go briefly, and you can complete this. So now we know what is the difference between descriptive and influential statistics. Descriptive statistics is for sample population, and influential is for population. So enter the appropriate symbol in the following table. So for mean, my sample is something x bar, and for population it's mu. For standard deviation it's s, and for population it's something like this, right? So now third number question is, if you want to know the length of beard of students in Australia, and you know that the population mean is this much and standard deviation is this much, so what would be your mean sampling distribution, mean uh, mean millimeters of sampling distribution of the sample mean? So we already know my sampling distribution of sample mean will be approximately, my sample mean will be approximately close to my population mean, which is mu. So we already have population mean. So my answer will be 3.3. So what is central limit theorem? Central limit theorem says sampling distribution of sample mean is approximately normal provided my n is greater than equals to 30, right? And fifth number question is, so you know your sample size is larger than 30, right? And your data is right skewed. So so this is right skewed, right? This figure is right skewed. So central limit theorem says my data should always follow symmetrical. Normal distribution should be symmetrical, right? So you know that your sample size is greater than 30. This could be a population distribution or data distribution. This is a sampling distribution. So it will not be a sampling distribution because for sampling distribution, it should follow normal distribution. It should follow normal, symmetrical, bell-shaped curve, right? So this is not a sampling distribution. It could be, this could be some population distribution, data distribution, or so it cannot be all three. This is also not correct. So this is a population distribution. So this can be either a population distribution or data distribution. So this would be my proper answer, not this one. Yeah. So what conclusion can we draw if our data distribution is completely different from the corresponding population distribution, provided the sample is large? So what conclusion can we draw is data distribution or sample distribution, both are same. So what conclusion can we draw is, if I have a sampling distribution, that will always be symmetrical, and if I have data distribution, then my curve can be right skewed or left skewed or normal. It depends. Even my if even my sample is large or not, right? So that's the conclusion we can say. So I have discussed this briefly. Later you can do it on your own. Okay. So any question? Okay. So we will start with Python. So that's it for today for our. Try to do this quiz question by yourself. I have also added quiz for 1, 2, 3, 4.
Is this for R?
Yeah, this one was for R.
Okay.
Right now we discussed was for R. Okay. So we will start with Python. Okay, let's take a 5-minute break and then we will start with Python. Then. Okay. Let's quickly go. Hmm. Hello.
Yes, sir.
Okay. So today we are in week 7 for Python. I have also added one assignment for
This is week
Python.
8. Or we're
Yeah,
doing 7 Python.
yes. So yeah, we are in week 8, but the Python we have started Python when we were like in second week, I think.
Okay,
We
okay.
started Python. That's so. I have also added one assignment, two. So, did you try assignment one? Did you try to complete assignment one?
Sorry to say, actually, not yet. But
Yeah.
definitely, like this week, I will
Yeah.
do all the things because I'm even revising all things from the starting.
Okay.
What I
Yeah.
have done. So yeah, once I'll done with that, I'll go to the all the assignments together.
Yeah. Yeah. Sure. Okay. Uh. Okay. So let me start. Okay, so in Python, we will start today with group by aggregation. So if you want to write something here, then you need to convert this into markdown. Okay. So once you convert this into markdown, then if you do control enter, you will have the information written there. So let's import my pandas as pd import by as np.
So I can't see a screen.
Oops, I haven't shared my screen, sorry.
That's okay here.
So we will start with group by aggregation. Everybody's here, right?
I'm here. I don't know what everyone is.
Yes, sir. Everyone is here. I think so.
So let's start with group by aggregation today. So this is
Yes,
my
sir.
this is my library, pandas and numpy, and let's read one file. So to read a file, we use pd.read underscore csv. So I'm trying to read. I have my data set inside. So inside data set, I have these files. So I need to go inside my data set slash. I'm trying to read census file, census.csv. And if I do df.head, this will give me header record. Census.csv does not exist. So it should be data typo here. So we can say this is my census data. So it contains this data contains the estimation for year-wise estimation of total population based on state and city. So if we look for df.columns, it will give me all the header information. So I have region, division, state, country, census, estimated based on 2010, 2011 to
DF means
2012.
define, like definition. DF means.
Df, I have defined this as, so it is a data frame, right?
Okay, okay. All
So
the
that's
files
why
that we have uploaded. So
in
DF.
data frame, that's why I have given this name as df. So in order to do some subtraction or addition, so we need to, let's create one more field. So that field will be my difference of 2010 and 2011 estimation. I'm trying to take a difference of 2010 and 2011. So diff population estimate of 2012 underscore 2011 equals. So you need to have a proper name so that any other who is reviewing your code can understand what you are writing, right? So your code should be readable to every individual, whoever is viewing your code. So you should give a proper name whenever you do some work. So you are taking a difference of 2011 and 2010 population. So your a new column should have that information. The information should be meaningful. So I am doing a difference of 2011 and 2010. So I will write here 2011 and 2010. So what I'm trying to do is I'm trying to create one more field. So if I give, so I'm trying to do subtraction of 2011 and 2010, and I'm trying to store that information in one new variable, new column in my existing data frame, right? If we do this, and if again we look for df.head, then we will have this information at last. So this is the new column that we have added right now. Okay. So let's say if I need to do aggregation, like I need to take sum of the this field, sum of population estimate of 2011 and 12, based on my based on some level. Okay. So let's check what I have in some level. So if to check my distinct value in some level, what I will do is some live dot unique, like unique. So in this field I have two unique values, 40 and 50. So I want to take the average of.
What is some level?
So this is my column.
Oh,
This is my column. What does 40 50 means? This is divided into two parts. Let's say you can say like two groups. One denotes 40, one denotes 50. You can say, you can assume that way. So some live have two numbers, 40 and 50. You can say that we have two groups here. One denote 40, one denote 50. So I want the average of my difference that I have calculated. I want to take mean based on this field, some live. So for 40, I want to see average difference of population estimate of 2011 and 2010, and for 50, I want to see the average estimation of 2011 and 2010. So what I will do is we will use group by, right? So like we do in SQL, so group by always follow with aggregation, right? So we should have some aggregate function so that we can do a group by, right? So group by means like combining all information. So if we combine all information, so we need to use, if we combine, so after combining the information, so the way of combining the information could be to take either sum or count or average or mean, right? So we are combining that information through aggregate function that can be sum or average or mean, right? And we are grouping that based on some level. So to do that in pandas, what we do, df dot group by. So my group by will be on basis of this column, some live dot means aggregation, right? So we want to aggregate on the basis of this field, right? We want to aggregate on basis of this field, and I want to take my average on basis of this field. If I run this, then I will get my average on basis of this field, right? Likewise, we can do aggregation. Right now we did aggregation for only one field, and we took average. Similar way, what we can do is we can add more aggregation here. So inside bracket we can add uh, np dot nan std. What nan std means is it calculates standard deviation, and nan means it ignores log value, nan cases, right? So this gives you so it should have on closing bracket. Yeah. So this gives me average and standard deviation of on the basis of these two columns, not two columns, for one column for these two groups, 40 and 50. So likewise, if we need to add more aggregation, we can do here comma, and let's say I want estimation of 2010 population even, and give a semicolon. You can add like non-average. If we add that, then we have average for population estimation 2010. So in this way, we can add as many aggregation we want. Right? So if we want to group on the basis of two columns, we can give here inside the bracket. You can add, you can do a comma and can add and close the bracket. That will be adding from one more. So this is how we do aggregation. Any question here?
No, sir.
Okay,
Almost.
so now what we will do is we will do transformation. Transformation, what does this means is, right now we aggregated the information, and this is my aggregated information, right? So if I want to have this aggregated information inside this data frame, so I want to see the average for 40. So my average for 40 is this 4,600, 46,509. So I want to have this information in my data frame here, in one more column, right? For that, because this aggregation gives you the aggregated result of particular, for example, here we took aggregation for some level. If you want to, if you want to have this field in my data frame where my individual some level, for example 40 gives me, in this data frame it gives me an average here. For that, what we need to do is we need to do a transformation. Yeah, so let's say my column is, so what I'm trying to do now is, so I'm trying to have this information. Right now we have, so this information I'm trying to add that information inside my data frame. So this information here we see, this is the aggregated information, right? So but this information, if you want to see in your data frame, how you will do is we will use transformation, right? So in transformation, I will copy two columns, this comma.
So the average that you calculated, this is like mean we
Yeah,
calculate
yeah,
for the,
me.
is that for the whole table or just for the,
So for this data frame, it is for this data frame, we have
for whole table, yeah? You mean to
data
say?
frame, data frame.
Okay.
In Python, it's data frame. In SQL, it's table. Okay.
Okay. So even sir,
So
I think for the average we can also use the mean. So in this
yeah,
one, like,
you can even use a
uh,
nan mean. You can even use nan mean. Both are same.
okay, because like I think it comes in NumPy array, isn't it? Like these all functions, or in pandas.
So
I
yeah, so your mean standard deviation max all comes under NumPy.
NumPy. So this is NumPy function.
Yeah, so it's a NumPy concept. That's why we did NP. So I have explained to you this in my week, in week third, I think. In
Yes,
week third.
that's why I was just
Yeah. Okay.
remembering the.
Okay. Sure. Okay. Okay. That's good. Uh, so to transform underscore df. So what I'm trying to do is I'm trying to add this mean and standard deviation information in my main data frame. So how to do that is, keep bracket columns dot return dot transform np dot nan mean. If you look at the header, now for each row it will give you a sample, your average mean, right? So for my this row, first row, for 40, my sample mean should be 46,509, right? So for 0, your sample mean is 46,509. Likewise, for second row, it's for 50. For 50, your mean should be 754. So it's giving 754. So this the use of transform is it adds the information in your data frame. This information is added in your data frame. So if you want to add this information in your data frame, so what you can do is, let's rename this first. So to rename this column, what we do is dot rename bracket. So to rename the column, we need to have a dictionary, right? So my column name is this, then this needs to be renamed to something like, let's say, so this is now, this is my mean difference, right? This is not my, this is not a difference of 2011 and 2012 year, but now it's a mean difference. So this we name it to mean difference. Now axis will be equals to column or one. Column or one both denotes that we are looking column wise, not row wise. In place equals true means we are having this information, changed information permanently, right? So if, so this is my transformed. So you can see the changes, right? So now what we will do is we will merge this information in my main data frame, right? So to merge this information in my main data frame, what we do is we use merge. This one I have discussed in my last lecture. Df.merge to combine these two tables. So I will combine my df with transform merge, and what I will do is, this is my index, right? 0 1 2. So my index in both the data frame will be same, right? So my left underscore index is equals to true, and right underscore,
Can I ask one question? Like here we use the merge function, but even the concat function is still same. So can't we use concat
yeah,
like
we can,
combine
yeah, we can even use concat, yeah,
concat as well? Yeah.
yeah,
So like in so that should would be like df dot concat and the
yeah,
other syntax would be same. Yeah.
yeah, yeah. So right now we are doing merge, we can even do concat. So we are joining on basis of left and right index. Okay. So if we look now, so this is my transform. So we have already given the left index here, so we don't need to give this to time. So here you can see your mean information is added, right? So this is the user transform. And then once you are able to add the information in your main data frame, what we can do, we can even do filter. This filter is similar to using having in SQL. In having, we do to aggregate my mean, right? So likewise, if you want to do aggregation of your mean, you can use filter in pandas. So if you do df dot group by some live dot filter bracket lambd lambda of x plus that and p dot nano mean of x bracket. This mean is greater than. Now right now let's take this difference, because that mean only have two values. That's, that's what let's say take this field is greater than, let's say 757 780 is 2, because here we can see equal to 593. So if we do this, this will give me all records where my mean of this field is greater than 780. So here we can see all values greater than 780, right? So I have discussed about using lambda, right? So to use lambda, so this is how we can use lambda and can do a filter. So using lambda, let's do a quick division. So if you want to do x such that if you do a plus b, right, x plus b, if you do a of 5, then this will give you a plus a. Hmm, x times 2 into, okay, so this x needs to match, right? So if you do x times 2, this will give you 10, right? If you do here, if you do np dot then mean of x, if you do, if you take mean of 5, it will still give you 5. So here we can do all sort of manipulation, right? So this is what we did here. We took the mean and we filter our record that is greater than equals to 780. So in this way we can apply lambda and do filter. Okay, now let's move to pivot table in Python. Let's use another data set, id.read underscore csv bracket data sets slash cw ur data, okay, csv. Mm, okay, this. So this data contains the ranking of all the university based on each country. So here we can see the rank level, national rank. See Harvard University is on first, Massachusetts is in second, Stanford in third, right? So what we want to do is if we look at my df.rank national underscore rank dot unique, if we look at value, so my ranking ranges from 1 to 229. Now what I want to do is I want to categorize my ranking so that if the if the rank is between 1 to 1 to, let's say, 100, then this is my first class institution, okay? If my rank is between 100 to 200, so this is my second class institution. If my rank is between 200 to 300, then let's say these are other institution. So if I want to aggregate this information in this way, how can we do this? Here is how can we do this? Any idea? So we will create a function. Let's say create underscore category and rank. If my rank is is greater than or equals to 1 and my rank is less than or equals to 100, then this would return first tier top university here. Let's say if your let's say if your rank is greater than or equals to 101 and rank is less than or equals to 200, then this would return second tier top university, or else it should return other top university. So this is my function. So to apply this function in my data frame, what we need to do is we will create a new column that would be my rank label, and we will pass. So my column name will be this national rank, right? So we will pass here left bracket national underscore rank dot apply bracket this function. If you do this, what happens is now your rank is replaced by national rank. So the rank is now replaced by national rank. So if your national rank is between 1 and 100, it will return top tier university, and then it will store the information in rank label. Likewise, if your national rank national rank is between 1 and 100 and 200, it will return second tier top university and store this information in rank label, right? So if we run this dot here we do, so here we can see this is my first rank 1, so this is first tier top university. Now what we need to do is, so now I want to pivot this information. Now what I want to do is, now I want to use a pivot, and I want to convert this information from column to row. So I want to have my information in, so this would give me like first top tier, and here should be my country, so the for example USA, and here the score is 100, so top tier should be 100. Second top tier should be, suppose if there is something other score, so this is my score. Yeah. So my score, this country is my, this is my index, suppose if this is my index. So I want information something like this. So this is, So in pivot table, what we have is we have three things. We have values, and then we have index, and then we have columns. Okay. So values means this value, what you want to present in this value, and index will be your row. This index, what would be what you want to populate in your row, and your column will be what you want to have in your column, right? What you want to have in your column. So this is my syntax for creating pivot table in pandas. So what we will use pt.pivot pivot underscore table, and my values is, suppose I want to store score, and my index is, I want to keep my index as country, and I want to keep my columns as rank underscore LEVE11. Now what I want to do is I want to aggregate my column. So my whatever the score information we have here, I want this score information to show mean of score. So what I can do is use aggregate here. AGFUNC, and can use here np dot mean. If we do here dot head, so my data frame is df. I need to give df here. Uh, Column name is rank on underscore level. Okay, so here we can see mean of. So this has we can see pivot table in action. So this has been converted in columns, has been converted into row. So we have created three aggregation. One was my first tier, second tier, and the other university. And the information of my country is in index. This is my index, and this value is mean. So it is, so a mean score. Okay. So likewise, we can add one or two, any number of aggregation we want. You can add here. You can do a comma, np dot. Suppose I want max, np dot max. If I do this, then can have one aggregation is on my a max. This shows max, and one aggregation shows mean. Shows mean. Now here we can see mean and max information. So Argentina has a mean score for first year top university is this much, and his maximum score is this much. For first year university is 45.66. So now we want to have another column that will show the maximum value of these two field, 44 and 55.6. What we can do, we can add a margin here. So if we add a margin, if we do comma margin, margins equals to our true, this will add overall sum here. So out of these two, so dot margins equals to, I don't know what aggregation did this do. I think this is taking this I think this value is mean of this and this. Let me check. I thought it would give maximum value, but it is not giving maximum value. So margin equals true. Let's check what this is doing. 44.67 plus. So this should should give, yeah, it's giving maximum value. Here we can see 44.67, 45.66. So this is giving us the maximum value, right? So out of this 44.5, 51. So this is not giving maximum value. This is giving a summary for my mean and max both. Sorry for that. So for my mean, my overall value is 44.67. For max, my overall value is 55.66. So if you add margin equals true, we'll get overall value. All this all value. So now we have this information. We have mean, and then we have first year top university. So if we want to query information, so if you want to look for the value of what are my top tier university, so it is under mean, right? So to query this data frame, what we need to do is
So
df.
why we write, sorry, like the margin is equal to true?
So if you want to have the, suppose if you want to have overall information here, all you can see, right?
All.
So for mean you can see the total, and for max you can see the total. So margin equals true gives you the total.
Okay.
So if you want to query now, if you want to see the mean top tier first year top university mean, if you want to see this information, what you can do is give a mean. First level is your mean, and second level is your first top tier university. Top tier. So let's store this information in new data frame inside df.new. Now let's use this. So in this way you can fetch your information. Right, for mean first year university, you can say Argentina, this value. So out of these values, if you want to look for the maximum value of your tier, like in first year top university, what is your maximum value? If you want to look that which country has the maximum value, you can do is you can do dot idx max. What this does is it gives you the maximum index, like the value that has maximum score. It gives you that, and since we are setting our index as country, that's why it gives you the country that has highest score. That's in Belgium, right? We can see here Belgium has the highest score. So right now we are storing dot head. That's why it is showing Belgium, because it is only showing for 5 university. So if we store all information, we look now, so it's USA, right? So USA is your top tier, first top tier university. So we have stacking. uh, Stacking means converting your information, like right now your information is in, if you want to convert this row level information into column level, then you can use stacking. Let's say for example, so if you do db underscore new equals db underscore new dot stack, if you look at the db underscore new, it will convert your all value into column, right? So my information was in the row. Now this has been again pivoted into column. This is up to field rank level. So, okay, so this is showing you in. So it has converted your row into column. Again, not stack will convert your all row into column. Okay. Any question here? So high level information will be as is,
Yeah.
and then it will convert into this into. So this is stacking. So likewise, we also have on stacking. So on stacking does the opposite. If we do on stack, it again converts your data into original data frame. Originally we had this information, this table, right? So this again converts your data into original. On stacking will again convert your data into original data frame that you had. So now you might be wondering what if I try to do double on stacking, right? So this converted your data into original data frame. If I do dot on stack and then again dot on stack dot head, so first on stack will so first on stack you converted your data into original data frame, and second on stack converted your data again. Did it converted your row into columns, right? So this is the output if you do double stack. Now let's look at date time function. So we have time stamp. So time stamp it represents a single time stamp and an associates value with points in time. What does this mean is if we do pd dot timestamp p of let's say 9/1/2019, say 10:05 a.m. if you do. So if you convert this into timestamp, it will convert your date into original time period. Like it will convert it into year, month, days, dd, and yy. Minute, hour, minute, second. This is hour, minute, second. So you can also do pd dot timestamp and then 2019. Suppose 12 December 20 0 minute 0 second. If you do, so it will automatically convert into your date time. Likewise, if you give that ISO weekday. This will show you which week it is. Like for example, 2012, 2019, 12, 20 is your fifth week. So if you do likewise, if you do, so it's not a fifth week because we will not have, it's fifth day of a week. So time is 2019, 12, 20. If you do 5 hour, 2 minute and 23 second, and if you give me a second, then it will give you the second information, 23 second. Likewise, we can use period. So if we do pd dot period of let's say 1/2016, then this gives you information in month level because we have only mentioned year and month. Again, if we do dot period, if we keep 3/1/2016, this will give you information in day level. It looks at most granular level. So here the more, here we can see the most granular level is D. That's why it gives you the D. Likewise, we can even add. So plus with plus 5, if we do, this will add your month. This date, if you do minus 2, this will subtract your month, subtract your day. So likewise, we have date time index and period index. So let's say I have one cities, pd dot cities. At cities, I have a list. ABC, suppose 3 columns in a list, and then I have my time. Let's copy this. So I have 3 index here, and my list is ABC. So if I look at type, so what type my index is, if I do type here, this will give something. So my type is index, datetime index. Okay. So likewise, if we store this information as dot period, just now if you look at type of T1, so now it's period index. Now we will look at converting to date time. So let's say I have data that has different date format. Let's say I have one is 2 June 2013, and another is August 2020 from 2014. Another is in proper date format like 2015, 16, 01, 20. Another one is it's a 7 slash 23 slash 16. So if I create a data frame, so pd dot frame. So I am creating a random data set. My value will be ranging from 10 to 100, and my size of a data frame is 4 columns, 2 rows. My index is dt, and my columns are, let's say, stuff ab. So what we did here is we created a random number from 1 to 100. From 1 to 100 we have given 4 values. So this is my 4 values and 2 columns. So someone can ask you to create a data frame that holds a random number and have 2 columns and 4 row. So if someone asks you to create a data frame, this can also be one interview question. So I can create a data frame, a data frame that has a random number ranging from 10 to 100 with 4 rows and 2 columns. Someone says to create a data frame, it has a random number ranging from 10 to 100 with 4 rows and 2 columns. You can create in this way. So this is my random number that ranges from 10 to 100, and my size is 4 rows and 2 columns. So here you can see my index here has different date format. So to convert this into proper date format, what we do, dt.index will be equals to pd dot underscore date time bracket dt.index. So if we do check this, so now the data is in proper date format. So to underscore date time converts it into proper date format. Also we have pt dot to underscore date time. If we have a format like 4.7.12 day first equals if we give day y. So this converts my data entry, this is a European format, so which we have given day as my priority. That's why we have converted this into. If we don't keep this, then we'll have 0407. Okay, so day first we have given this day as a priority. That's why we have 704. This is this is how we convert my date into European format, European convention. So to subtract two dates, we have time delta. So PD dot time stamp of 9 slash, let's say 3 slash 2016. We want to subtract two data frame, two time period. 9 slash 1 slash 2016. So this is a difference of 2 days. So 9 slash 2 slash 2016. So we can even add something like, if you want to add 12 days, 3 hours, we can even add this. Let's say subtract. Okay. In this way, we can add even a specific date and hours if we want. Now we will see, we will work with that same data frame. Are you guys there?
Yes, sir.
Okay, so let's take a quick 5 minute break and we will start again.
Sir, I
Yeah.
have to leave at 10:30 as well, as I told you yesterday. Is that okay?
Okay. Okay. Mm,
So what else we need to do today?
sorry.
What else we need to cover today? Which other topics?
So yeah, we will complete this date time feature in pandas, and that's it. So upon completion of this, it will not take much time. So let me complete this then till 10:30. Yeah. So working with dates in data frame. So to add date range, we have P. In pandas, we have date range. So if my date is, let's say, 20/01/2016, and if my period is 9, and my frequency, let's say, 2 week Sunday. So if we do this, so this, what this does is it adds your data on bi-weekly basis, every 2 weeks. So your frequency is every 2 weeks Sunday. So it looks, so this date will be added after 2 weeks. So first one is your 2016/01/24. So after 2 weeks, Sunday will be 2016/02/07. Again after 2 weeks will be 21. We can see 7 to 21. 2 weeks jump here. So this does 2 weeks jump because we have set our frequency as 2 week. Likewise, we have feature here, like if we do B means business days. It looks for business day, and it will skip your Saturday or Sunday, like 20, 21, 22, 25. You can see here 23, 24, Saturday and Sunday is skipped. So B refers to business day. Likewise, we have, uh, let's say my quarter starts from June. So we can even do quarter QS starts from JUN, June. If we do, so this will give me a result on quarterly basis that starts from June. So let's say if I have this data frame, so we can even do slicing and dicing in data frame, and even if we can do aggregation in data frame. Like for example, this is my data set, and it gives you the count of every week to 16, 30. If you want to aggregate this in monthly basis, then what you can do is you can use the sample method. This is very important for aggregating date. If we do the sample and if we give here m, this will take this will aggregate your data on monthly basis. M means monthly, and if you take mean sample PLE, this will, so you can see 31, 1031, 1130, 1231, 131. So this will combine your data, aggregates your data in monthly basis, and it will do mean. So here we have data on a weekly basis. This has been aggregated into monthly basis and takes the mean. Likewise, we can even do slicing and dicing. If you want to see only 2007 17 data, you can even simply give 2017 here. So in 2017 we have two records. Likewise, you can give 2016 here. If you want to see the record that starts with particular date for 2016, so let's say if you want to see it starts from 12-12, you can give a semicolon here, semicolon outside here, like it. You can see all values starting from 2016 12. So this even we can slicing and dicing even we can do inside data frame. Once if my data frame is a date format, we can even do slicing there. So this is the end of the Python in pandas. We have covered everything, not everything, the most important thing we have covered in pandas. Hmm. So I have an assignment here. So I have added an assignment here. What we need to do in this assignment is we need to import three files. Okay? Your first file have something information like this.
These files are already in GitHub.
Yeah, it's already in GitHub. It's inside your. I have mentioned the location inside dataset energy data. Okay, so here you have dataset data energy data. Okay? So if you look at the dataset, so your data is something like this. Okay, so what we need to do, you need to import this data first, try to load this data is in XLS format. So to import data in XLS format, we use read underscore Excel, pd.read underscore Excel we use, and then read this file and store in variable like we store variable. We have stored this information in we have read underscore CSV. Likewise, we need to do read underscore Excel. We import Excel file, Excel, and then my data frame. I want this information to be stored in data frame as energy. It is stored that in energy variable. Okay, and then what you need to do, you need to do some data cleaning after importing files. So you need to exclude your footer and header information. So here we can see this is my header information. So my data starts from here, 19, right?
Mm. Okay.
19, 26, and 25 it starts. So you need to skip your footer and header information from these two files. And also you need to remove unnecessary columns. So your columns would be this much, two, three, four columns, which is this. This is my first column, second column, third column, fourth column. So you need to clean this information and you need to make sure you have replaced all NaN cases, and you need to convert your energy supply to. So here we have energy supply field, energy supply. This is in data jealous. You need to convert this into in gigajealous. So this much gigajealous is a gigajealous. So you need to do a bit of math.
Gigajoules is just a name.
Sorry.
It's a name. Gigajoule is just a name, isn't it? Like convert energy.
It's like a kilogram,
Uh,
liter, gram, kilogram.
here, like we are doing all these things in R or in Excel.
So you need to do this thing in Python, like we do
Using pandas. Okay.
using pandas. Okay, and then we have another file. Also, you need to rename the volumes. Like the Republic of Korea is here. If you choose the Republic of Korea, you should have Republic of Korea in this country name. You need to change that to this country. Try to follow these steps, and then we have another file here, GDP data. This is my one data. And we have another data set, GDP data. So also try to import this file and skip the header information, skip this header information, and try to rename this field. And then we have one last file. So we have three files. So you need to import that three file and you need to merge all that three file into one data frame. The final goal will be to merge all three files into one data frame. This is network file. You need to join the three files and you need to include these columns. Okay? To join this file, so we will use pd.merge. First, we will import the file. So first, we will import the files, all these three files, and then we will merge, join these three files. After joining these three files, we need this information. So if you read this and clean some sort of data, then you will have some understanding about how to rename columns, how to clean fields, right? How to merge three tables. So if you do this part, then you will have good sense of a bit of sense of importing data, cleaning data, renaming columns. So all that information you will gain if you do this. This is your assignment, and I will add more questions if you are able to do this. I will add more questions. So what I should try to do this first. Try to complete week 4 first, and then week 4, and then this one. Okay, week 7. Hmm. Okay, so I don't have anything in my end for now. So, do you have any question? You want to ask something? Do you have any confusion? If you want me to explain something. So, right now, what we are in stage, we have completed our Python pandas even. So, as per our course structure, we have completed week 1, week 2, and week 3 part. So, week 3 part is for Excel. So, I have given you 2 case studies to practice. So, in week 3, I have given you the 2 case study to answer to practice that case study and draw a dashboard. So, you need to complete that. So, your assignment is, I can list your assignment. So, first for Excel dashboard and analysis as per week 6 you have to do. So that is on your face. So once you complete that two data set I have given here, we can move on to more data set and do more practice. And then so in the statistics we have covered the central limit theorem till here, and the last one is remaining. And then one project is also remaining. In SQL, we have completed this data cleaning event, exploratory data analysis we did yesterday. So this is almost done. In Python, we have completed this too. And from next week, we will start exploratory data analysis. And in Tableau, we have almost completed week 1 cleaning and week 3. And also we have made one dashboard. So we will complete week 2. This part is remaining, and we will even make one more portfolio project. So in Excel, you need to practice prepare dashboard and analysis as per week 6. You need to do. In Python, you have two assignments. Two assignments. Assignments. Are given 5 quiz questions. 5 quiz questions to practice. Practice. Assignments in Python. Quiz question to practice. In R. In SQL, we have one project. This is under your work to practice mastering join. SQL is remaining. So you need to complete this even, practice this. SQL. So even in Tableau, I have added all practice question here. So prepare a dashboard based on new instruction. So dashboard preparation. Tableau is also remaining. So you need to complete all this. That's before before the end of our 12th lecture, before the end of our last lecture, we need to complete all these things. Yeah. So that's it from my end. Do you have any question for today?
No, sir.
Okay, then see you next week. Javadi, do you have any question?
No, sir. No.
Okay.
So, sir, next week, what we gonna practice? Or what
So
we gonna do next week?
so next week we will do exploratory data analysis in Python,
Okay.
and yeah, we have in probability, even its probability and statistics is still remaining. And once we do that, in so my plan is to complete everything till 10th week.
Okay.
In 11th and 12th week, we will only do projects. And last 2 weeks, we will.
All right. So 12th and 11th week, what we gonna do?
Sorry.
So on 12th or 11th or 12th week, what we gonna do?
We will do projects on R and
Okay.
Python, and even
Okay.
everything we will revise, and we will do mainly we will focus on projects in the last 2 weeks.
Okay. Okay. Okay.
And even
Okay, sir.
the queries, if you have in any assignment or any questions, quizzes, if you have any queries,
Okay.
we will even cover that in the last 2 weeks.
All right. Okay.
Okay. Then that's it for today.
All
See you
right.
next week. See you next week. Thank you.
Okay.
See you
Thank
next
you.
week. Thank you, sir.
Thank you.
Bye.